Friends, welcome to the 11th lecture in module 3. In this lecture, we will talk about the use of artificial neural network in structural health monitoring processes. In the last lecture, we discussed about the use of artificial intelligence in general compared to the computational intelligence and how the interference helps us to improve upon the intelligent sensing and decision making processes, which are very vital and important in structural health monitoring scheme or a network. So, in this lecture, we will extend that artificial intelligence source of information to a neural network and see how this can be useful in simple applications as far as SHM is concerned. When we talk about use of artificial intelligence in structural health monitoring, there are about 4 axioms which are very useful and directly applicable. Axiom 1, in that case we should name this as per the order explained in the literature. So, we should say axiom 3, which says identifying the existence and location of damage can be done in unsupervising learning mode identifying the damage, or to be very precise, identifying the type of damage present in a system, severity of the damage, only by supervised learning mode. Axiom 4a, it says that sensors cannot measure damage, they only record the data, they do not know really whether the data recorded pertain to damage or not. Okay. Sensors cannot measure the damage, it is only through the feature extraction done through signal processing and statistical analysis classifies the damage from the sensor data. It is very important axiom. The next axiom is a subset of this. So, I call this as axiom 4b. Without intelligent feature extraction, changing operational conditions and environmental data makes the measure data of damage more sensitive. It means Any change in data related to operational condition or environmental conditions may always give a false implication that it is relevant to a damage. You have to confirm that it is a damage only through intelligent feature extraction. So, without intelligent feature extraction, the sensitivity of these two parameters will become very dominant. Okay. Axiom 5, the length and time scales associated with damage initiation and evolution decide the properties and characteristics of the health monitoring system. They govern how long you want to and how and what interval you want to measure the damage parameters to really identify the damage initiation and evolution. It decides what is your characteristic of your health monitoring system. Okay, that is very important. The intelligence in structural health monitoring can be useful in composite structures. So, the main aim or the hidden agenda here is using a robust type signal processing protocol. Let us take an example where the composites are subjected to damage very often. One classical example is glass fiber reinforced plastic. That is GFRP. Laminates are generally or let us say widely used as structural materials because they have high strength to weight ratio and good corrosion resistance. They are also useful in military applications because they minimize electromagnetic radar signature on underwater vehicles of GFRP. They fail mainly due to cracking or delamination. Delamination is more severe because it causes stiffness reduction and leads to catastrophic failure of the structure. So, therefore, friends, it is vital to detect delamination in GFRP. The more vital part is a few delaminations may be, but still they can cause severe damage to the mechanical properties and load carrying capacity of the structure. There are various techniques which are applied to check this delamination. One is X-ray, 2 is ultrasonic C scan, the third could be laser shearography. Now, with these methods there are some difficulties. The difficulties are, it takes much time to inspect the laminate or the GFRP structure by these techniques. Therefore, what is desired? The desired option could be online detection of damage. What is online detection? How it is done? Artificial neural networks, pre-processing tools such as damage relativity analysis technique, which is damage diagnosis. Now, the advantage is this can predict the location, size, presence and extent of the damage precisely. Now, let us see more detail about this artificial neural networks. They are actually a large parallel distributed processors comprising of simple processing units. These units are called neurons, which has multiple interconnection paths. Mapping the relationship between measurable features of structural damage to their physical parameters. For example, what kind of damage would cause what change in the physical parameter or property? This can be identified and established using an artificial neural network. Classification and identification of structural damage can be successfully done using artificial neural network. How does it do it? It uses a set of known damage features and their corresponding physical parameters. It also employs multi-layer feed forward back propagation network. To perform data segmentation, data compression, and above all, most importantly, the pattern recognition if present by identifying the repetition of data. Let us see how ANN can be useful in structural health monitoring in general. Are largely seen in bridge structures. For example, let us take a railway bridge whose health monitoring is required to be done. Okay. So, the steps could be very simple. Data should be collected from the dynamic response of the bridge through simulation, under passage of train, okay. When this is done, it is assumed that bridge is healthy, bridge is in undamaged state and it is therefore considered to be healthy. Which are different damage scenarios. In the first stage, I can use artificial neural network which are essentially trained with an unsupervised learning approach. The input comprises of accelerations of the deck, under healthy state, now based on the acceleration values, at the previous instant of time, the neural network predicts the future acceleration In the second stage of damage prediction, in the second stage of damage scenario, the prediction errors are statistically characterized by a Gaussian process. Which supports the choice of damage decision, the choice of damage detection decision from a known threshold value. By comparing the damage indices, with the threshold value, one can differentiate the health conditions of the bridge, whether it is damaged or healthy. Okay? One can decide this. For each damage case scenario as seen above, operating characteristic values in form of curves are obtained. Then using Bayes' theorem, one can also estimate the total cost of the proposed methodology.